Good morning, students. Today we are going to discuss about radioactivity. Okay, students, right? Okay. Now come to the definition of radioactivity. Right? So in last class we gave some instruction about radioactivity. Okay. Now see this one. The nucleus of some elements is unstable. Right? So such nuclei undergoes nuclear decay and get converted into more stable nuclei, right? And during this nuclear reaction, these nuclei emit certain harmful radiations and elementary particles. The phenomenon of nuclear decay of certain elements is called radioactivity elements. Okay, right? And yes, continuation. The nuclei of radioactivity, yes, we know that. The nuclei of naturally occurring heavy elements like uranium, thorium, and radium and polonium are unstable and keep on emitting spontaneously invisible radiations like alpha, beta, and gamma rays and give more stable elements. Okay, so uranium, yes, thorium, radium, and polonium. So these are the some radioactive active elements, right? Okay, and it is the nucleus of an atom of an element which spontaneously disintegrates to emit alpha, beta, and gamma rays, right? And the rays emitted by radioactive elements are called radioactive rays. So please listen. The rays emitted by the radioactive elements are called radioactive rays. Okay, right? Okay, and is the process of spontaneous disintegration of the nuclei of heavy element with the emission of certain types of radiation. Okay, so these are the details about what radioactivity. And now the radioactivity classified into two types. One is natural radioactivity, another one is artificial radioactivity. See the natural radioactivity and artificial radioactivity. Okay, students, these are the types. Now first one is natural radioactivity. So this natural radioactivity, it is the process of spontaneous disintegration of the nuclei of heavy elements with the emission of radiation, right? So this is spontaneous. Spontaneous means continuously. Okay, at that instant time they are emit the radiations, and these are unstable nuclei found in nature. So these nuclei are unstable of nuclei found in nature. Okay, so natural reactivity is nothing but it is a spontaneous process. Okay, right. And now the elements whose atomic number is more than 82 undergoes spontaneous radioactivity. Example, uranium, radium, and etc. And there are only two elements which have been identified as radioactive substances with atomic number less than 82. So they are, yes, technetium with atomic number 43 and promethium pm with atomic number 61. Okay, so two elements are radioactive substance with atomic number lesser than 82. So they are technetium and the promethium, right? So one having atomic number 43, another one having atomic number 61. Okay, students, and these two are 1 mark. Okay, right. And do you know segment? Okay, 1 marks. There have been 29 radioactive substances discovered so far. So most of them are rare earth metals and transition metals. So up to this 29 radioactive substance. Okay, right. Continuation, natural radioactivity. All heavy elements above atomic number 82 show the phenomenon of radioactivity. The emission of radiation changes the structure of the nucleus and transforms the atom into an lighter atom. Okay, and the elements whose nuclei spontaneous disintegrate called radioactive elements. Yes, okay, like uranium, thorium, these are radioactive elements. Now come to the example of natural radioactivity. See this uranium, which gives thorium and alpha particles, and again thorium, which gives polonium plus one neutron, and here and again radium, which gives thorium plus alpha particles. Okay, so this is that example for natural radioactivity. Okay, and since the radioactivity is practically unaffected by the temperature, pressure, and other conditions, we conclude that it is a nuclear property. Therefore, alpha, beta particles and gamma rays are emitted from the nucleus. So, it may be noted that electrons revolving around the nucleus are not responsible for radioactivity. So, important 1 marks. The electrons are not responsible for producing radioactivity. Okay, students, right? Okay, and the radioactivity is practically unaffected by temperature, pressure, and other conditions. Okay, and next one is artificial radioactivity. What is artificial radioactivity? It is the process in which a stable nucleus is changed into an unstable nucleus. Important point, it is the process in which stable nucleus is changed into an unstable nucleus by bombarding in with the appropriate atomic projectiles like alpha, neutron, proton. Okay, so if that process of changing the stable nucleus into unstable nucleus, so we are producing that, which one, artificial process. Okay, okay students, right. See this example, artificial one. See, if you donate a parent and a daughter nucleus X and Y respectively, then the nuclear disintegration is represented as follows. So X, Y. Here P and E represent the projectile particle and ejected particles. So P is the projectile particles, E is the ejected particles. Okay, now here beryllium, what? Alpha, which gives carbon isotopes, and carbon S plus 1 neutron. Okay, so here C13 is unstable radioactive, it is isotope. Okay, and here this beryllium S plus 1 neutron. This 1 neutron. So here 1 neutron now. Okay, so this is the example for what? Artificial one. Okay, so the beryllium bombarded with alpha particle which gives carbon plus 1 neutron. Okay students, right. Again example, aluminum plus alpha particles which gives phosphorus and 1 neutron, and here boron plus helium 1 s neutron, and again carbon and 1 proton. Okay, so these are the examples of what? Radioactivity, artificial one. Now come to the difference between natural and artificial radioactivity. Okay, so is the spontaneous process. Natural radioactivity is a which process? Spontaneous process. Artificial one, it is not a spontaneous. Okay, so here since in natural radioactivity the nuclei of heavy atom disintegrate on their own accord, so forming slightly higher and more stable nuclear emitting alpha, beta and gamma radiations, right? But go to this side, since it is the nuclei of atom have to be bombarded by fast moving particles like alpha, neutrons and protons and deuterons. The particle bombarded with alpha, neutrons, protons and deuterons. Okay, now it is a natural radioactivity. See, it is uncontrolled and hence it can be slowed down or accelerated by an means, but it's usually shown by heavy elements. But artificial one, it can be controlled by controlling the speed of bombarding particle used for bringing about the artificial radioactivity. So we can control the activity. Okay, and it can be induced even light element, the radioactivity induced by the light element. Okay, right. And units of radioactivity, right? Units of radioactivity. See, the standard unit of radioactivity is Curie. So Curie represented by C. If the Curie is defined as the mass of radioactive elements which produces 3.7 into 10 power 10 disintegrations per second. So Curie's definition, it is the process, sorry, it is defined as the mass of radioactive element which produces 3.7 into 10 power 10 disintegration per second. Okay, students, right? Okay. And units of radioactivity. Yes, see the book content. It is the translational unit of radioactivity. It is defined as the quantity of radioactive substance which undergoes 3.3 3.7 into 10 power 10 disintegration in 1 second. Okay, but this is actually close to the activity of 1 gram of radium 226. Therefore, 1 mark 1 curie is equal to 3.7 into 10 power 10 disintegration per second. Okay, right? So 1 curie is equal to 3.7 into 10 power 10 disintegration per second. Okay, students, right? And another unit is Rutherford. Rutherford, it is another unit of radioactivity. It is defined as the quantity of a radioactive substance which produces 10 power 6 disintegrations in 1 second. Therefore, 1 radium Rutherford is equal to 10 power 6 disintegration per second. This is the another unit of radioactivity. Okay, right. And another unit is becquerel. Becquerel is the SI unit of radioactivity. It is defined as the quantity of 1 disintegration per second. Quantity of 1 disintegration per second. Okay, and the last unit is reagent. Yes, reagent. Okay, it is the radiation exposure of gamma and X-rays is measured by another unit called Roentgen. Okay, and one reagent is defined as the quantity of radioactive substance which produces a charge of 2.58 into 10 power minus 4 coulomb in 1 kilogram of air under standard condition of pressure, temperature and humidity. Okay, so these are the 4 units. What are the units? Curie and Rutherford, becquerel and reagent. Yes, so these are the 4 unit, but common unit is Curie. Okay, students, right? So this is the book content, difference between natural and artificial radioactivity. Okay, right. See this first one, emission of radiation due to self disintegration of a nucleus. Self disintegration of nucleus. But go to this side, emission of radiation due to disintegration of nucleus through induced process. Okay, but this side, alpha, beta, gamma radiations are emitted, but this side mostly elementary particles such as neutron, positron, etc. are emitted. This side it is a spontaneous process, but this side it is an induced process. We can stimulate the process, okay, with the help of particles. But this side exhibited by elements with atomic number more than 83. Yes, so more than 83. But here exhibited by the elements with atomic number lesser than 83. Okay, that is the main difference between artificial and natural. Okay, now so this natural radioactivity cannot be controlled, but artificial radioactivity can be controlled. Students, so these are the difference between the natural radioactivity and artificial radioactivity. Okay. Okay, students. So from this one marks will come. Okay. Okay, students. Okay, right. Students, today class is over. Okay. Today we discussed what is radioactivity and types of radioactivity and units of radioactivity and difference between the natural and artificial radioactivity. Okay, students. Okay. So please see on next video. Okay, students, please go through the topics. Okay, and underline some important points. Okay, thank you, students.